Hello everyone, welcome back to the Data Intelligence Hub. In today's video, we're going to learn about two important Databricks operations that can significantly improve the performance and storage efficiency of your Delta Lake tables, Optimize and Vacuum. If you're working with Delta Lake and Databricks, understanding when and how to use these commands is extremely important. Let's get started.
Why do we need Optimize? As data continuously gets written into a Delta table, especially through streaming, incremental loads, or frequent updates, Databricks can create many small files. Having too many small files can negatively impact query performance because the engine has to read and manage a large number of files. This is commonly known as the small file problem, and this is where the Optimize command helps. What is Optimize? So, what exactly is Optimize? Optimize is a Delta Lake maintenance operation that compacts many small files into fewer, larger files, with a target file size of approximately 1 gigabyte. But why do we need this? As data continuously gets written into a Delta table, especially through streaming jobs, frequent appends, incremental loads, and partitioned writes, Databricks can create thousands of small files. This is commonly known as the small file problem. Having too many small files can negatively impact query performance. When a query runs, the engine has to open and close thousands of files, read metadata for each file, and coordinate a large number of I/O operations. All of this creates additional overhead and can slow down query execution. Benefits of Optimize. After running Optimize, these many small files are compacted into fewer, larger files. This provides several benefits. First, there is less file listing overhead. Second, the engine can perform larger and more efficient sequential reads. And third, Optimize can improve data skipping efficiency, helping queries find the data they actually need more efficiently. Now, let's look at the basic syntax. We can simply run optimize catalog.schema.tablename. This performs basic file compaction on the Delta table. But what if the table is very large? We may not want to optimize the entire table every time. Instead, we can process only a specific portion of the data using a partition filter. For example, optimize catalog.schema.tablename, where date is greater than or equal to 2026-05-01. Here, Optimize processes only the data where the date is greater than or equal to May 1st, 2026. This approach is particularly useful when we want to optimize recent or frequently changing data instead of processing the complete table. Next, let's talk about an important feature of Optimize, Z-order. Z-order helps co-locate related data so that queries using specific filter columns can benefit from better data skipping. For example, optimize catalog.schema.tablename Z-order by customer ID, order date. In this example, we are using customer ID and order date for Z-order. If our queries frequently filter on these columns, Z-order can help improve query performance by organizing related data more effectively. Now, let's look at some important points to remember about Optimize. First, Optimize is idempotent. That means if the data is already optimized, running Optimize again doesn't keep changing the same data unnecessarily. Second, Optimize does not change the actual data content. Readers should see the same results before and after optimization. Third, Optimize does not interrupt concurrent readers. Delta Lake provides snapshot isolation, so readers can continue accessing a consistent version of the table while maintenance operations are performed. And finally, Optimize works together with Delta Lake time travel. Because Delta Lake maintains table versions, you can continue to query historical versions even after maintenance operations, subject to your retention and vacuum settings. Now, let's understand what vacuum means in Delta Lake. Vacuum permanently deletes data files that are no longer referenced by the current table version and are older than the configured retention threshold. By default, Vacuum removes files older than 7 days. The basic command is vacuum catalog.schema.tablename. If you want to specify a retention period, you can use the retain option. For example, the slide shows vacuum catalog.schema.tablename retain 30 hours. This is intended to remove files older than the specified retention period. So, why is vacuum needed? Delta Lake does not automatically delete old files when data is modified. Operations such as update, delete, and merge create new files, while the older files can remain in storage. Without vacuum, these unused files continue to accumulate, causing storage costs to grow. Vacuum also helps with compliance by permanently removing deleted or updated records from storage once they are eligible for deletion. But there is an important warning. Once Vacuum permanently deletes files, you cannot time travel to table versions that depended on those deleted files. So, Vacuum is an important Delta Lake maintenance operation for controlling storage, but it must be used carefully because the deleted files cannot be recovered through Delta Lake time travel. Important note for this slide. The comment says remove files older than 30 days, while the command uses retain 30 hours. These are different retention periods and should be aligned before presenting the final version. What is time travel in Delta Lake? Delta Lake maintains a transaction log of every change made to a table. This powerful feature, called time travel, allows you to query previous versions of your table and see what the data looked like at an earlier point in time. There are several ways to use time travel. First, you can query a table by version number. Select star from catalog.schema.tablename version as of 25. This retrieves the table exactly as it existed at version 25. You can also query by timestamp. Select star from catalog.schema.tablename timestamp as of 2026-05-01. This lets you retrieve the data as it existed on May 1st, 2026. And if you need to restore a table to an earlier state, you can use restore table catalog.schema.tablename to version as of 25. So where is time travel useful? It is extremely helpful for auditing and debugging, allowing you to answer questions like, what did the data look like yesterday? It can also help with recovering from accidental deletes or updates. And for machine learning, you can use historical snapshots to create reproducible ML datasets. However, there is an important limitation. Time travel only works when both the transaction log entries and the underlying data files still exist. This is where vacuum becomes important. Vacuum removes old data files, which means it can limit how far back you can travel in your Delta table. So remember, time travel gives you access to historical data, but only as long as the required transaction log entries and data files are still available.